When can you take a derivative, or sometimes called, is it differentiable? Can you take the derivative? If you look at number 1, almost every place on that particular graph, that almost looks like the absolute value graph, right? Almost every point on that is differentiable, except for one. And it's probably pretty obvious which one that is. Yeah, it's that one right where it comes together right there. Now, that is called here, something like that is called, according to this textbook and a lot of textbooks, a corner. Basically, I look at it this way. Because if that's where I wanted to find the derivative, right, I would like cast a point out this way, right, like fishing reference I gave you. You'd cast a point out this way and you'd reel it in, right, and it would give you an answer. Do you agree that would look, that's probably some positive slope right there if I do that, like maybe +1, right? But what if the fisherman turned around and said, let's cast this way and reel that one in? Is that the same answer?
No.
That's a -1, isn't it? +1, -1. Well, which answer is it? It's neither. Because at that point, we can't tell. Okay? So that point, this point right here is not differentiable. You cannot take the derivative there. Now, what about other points on that graph, though? Can you do it on other points, and does it work? Let's say this is the point I was concerned about. What if you cast one up this way and bring it in? Is that okay? What if you cast out the other way and reel it back in? We talking the same slopes there? We are. Okay, what about over here? Can I cast in both directions, and are we talking about the same answer? We are. And so those points are fine. All the rest of them are fine, except that one, that corner. No good. Okay? So right there, it's not differentiable, or you can't take the derivative right there. So that's one of those where if I give you a harder problem, you say, well, I'm just going to chop that half off, and I'm just going to look over here. All right? Because then you can't. Okay? That second one there, there's also a spot there that you cannot take a derivative. You can kind of tell I had to try and put this together. It didn't work very well, right? But right there, it is not differentiable. Well, is it for the same reason? Can I cast out this way and reel it in? Okay, I can do that, can't I? And can I cast out this way and reel it in? Well, aren't both of those kind of pulling that line the same way? This one's kind of pulling the line to be more that way, right? And this one's pulling the line towards that same thing, isn't it? But how would you describe that tangent line? What's a really good word for where that tangent line's working towards? Yeah, it's working towards vertical, correct? What's the slope of a vertical line? Undefined. So you're going to try and find an answer that's undefined? Good luck with that one. But how about any other point on this one? What if I'm just right there? Cast it out, reel it in, cast it out, reel it in. Aren't they both working towards that line right there? And is that a slope you can actually find? Yeah, that's not undefined. That's a slope. How about this one here? You cast that way, reel it in, cast that way. They're both working towards that one, right? Okay, we're kind of, when I say reel it in, we're going from that secant line to the tangent line, right? That's really what I'm talking about. It's going to that line. We can do that. Finding that one right there? I don't think so. So that one is basically just a vertical tangent is how they would describe that. And that's a problem. So far, was problem number 1 continuous? Could you graph that without picking up your pencil? But I couldn't take the derivative everywhere? Almost everywhere, right? What about number 2? Could you draw that graph without picking up your pencil? So that's continuous. But was it differentiable? Not everywhere. Almost everywhere, but not everywhere. Is this one continuous? No. All right. Yeah, there's discontinuities there, and that's actually what they call this one, is a discontinuity, is why there's no derivative there. Well, let's face it, if you're, like, you can't even check that point. It's not even there. Okay, it's up here. All right, so I can reel it in this way. Where do you cast to go? You cast down here and then whoops, get stuck. Yeah, you got stuck in the weeds, right? Your lure's stuck and you lost it, right? So how do you do that? You can't. You can't even reel it in. There's nothing there. You can't reel it in. And so there's no good. So that's a discontinuity. So this is one type of discontinuity. There's another one that this book doesn't even talk about, but is another discontinuity type. This is the step function, by the way, if you remember that from way back when. That was one of your parent graphs. This one we didn't talk about very much. What was another type of discontinuity that could possibly cause a problem? Asymptote, yeah, asymptotic. Mm-hmm. Let's face it, let's just do that 1 over x, right? Can you even, if you're at an x value of 0, are you even on this graph anywhere? So if you're not even on there, can you cast to the right and left? No, you're not even on there. All right, so there's a huge problem because you got those asymptotes there. Okay. How about right here, though? Can I cast both directions if I'm right there? Yeah, I can cast there, reel it in, there it is right there. Okay. But there's some points that aren't, and so it's no good. Okay. So basically, 1 and 2 were continuous, but weren't necessarily differentiable. 3 and the x factor there, the asymptotic, weren't even continuous. Okay? So that'll prove interesting later. The book adds this one. I think this is like a hybrid of 2 of them. Yeah, it's kind of like 1 and 2 kind of thrown together, isn't it? It's as if they forgot. This they actually call something else. You can call this a corner for all I care, but they call it something else. They call it a cusp. It's an extreme case of a corner. Because if I'm right here, I think that's obviously the place that's a problem, right? You reel out here, or you reel out here, you see how this one kind of starts tending this way, and this one tends the other way. They're almost tending towards the same thing. This one's tending towards a negative infinity slope. That's a positive infinity slope. Or they're really tending towards which of those tangent lines? The vertical. Are they ever going to get to the vertical? No. But they're tending towards it. And so that's once again a problem. So it's kind of a hybrid of 1 and 2. All right? They're not coming to the same consensus. They're disagreeing in a way. All right? When you reel it in. This is, I can't tell you how important this is right here. Those of you that take the AP, I guarantee there will be a question that deals with this. Obviously, it won't be this easy, but continuity versus differentiability. In other words, can you take the derivative? If your function is differentiable at a point, it will be continuous there, guaranteed, without a doubt. If it's differentiable, it will be continuous there. On the other hand, though, if it's continuous, are we guaranteed it to be differentiable? No, our 2 examples are, look at that, that's continuous, isn't it? Right there on number 1. Was it differentiable, though? No. Right there on number 2. Was number 2 continuous at that point? Yeah, it keeps on going. But is it differentiable? No. So keep these 2 straight. If it's differentiable, are you guaranteed that point will be continuous? Yes. If it's differentiable there, it will be continuous, guaranteed. Okay? If it's continuous, there's no guarantee it's differentiable. Okay? That's huge. Study it. Write it 100 times, whatever it is you have to do. Could it be differentiable? Yeah, it could be, but there's no guarantee it has to be. Okay? Yes. You can take the derivative there. The derivative is coming to that limit. Remember, derivative means that limit problem has an answer. Okay? Right here, does that limit problem have an answer for that point? It does not. It does not have an answer. Does it have an answer for this point over here? No, that limit problem does not have an answer. Okay? Maybe that's how you could look at differentiability. And that's why I took a long time on that slide. I want you to let that soak in, write whatever it is you need down on that one, because it's big. So for this example, I very nicely gave you the piecewise function. It's a little off, but it's pretty close. You gotta realize it's not that easy to do that, so. Okay. Determine which domain values the function appears to be: A, differentiable, B, continuous but not differentiable, and C, neither continuous nor differentiable. And for fun, let's just determine the domain and range. And let's do that first. Domain and range. This point's actually supposed to be down here. Sorry about that, I missed a little bit. That point I did a good job. That one's hitting pretty good. It's just that one point for some reason I couldn't get to work out. So where are we at there? For domain, we got 1, 2, 3, 4, 5, 6, 7 to the left there, right? And is that point included? So what should I write down? Okay, a -7 with a bracket all the way. Well, let's see. Are there any problems? Well, this has a hole here. Has that been taken care of? Well, it's been taken care of. Okay, it's down here, right? Whoops, down there. So we're good. So do we go all the way to that other black dot then? For yeah, and what is that? 1, 2, 3, 4, 5, 6. Is it included or no? Okay. So -7 to 6, we're good, right? And range, where are we at? Again, that's bottom to top. What's that? -3? Included or not? Okay. All the way to, what is that, 8? Right? Because it's normally 10, right, for the top, so it's 2 down, so 8. Now, the range part was more for review. The domain part actually could be very helpful in answering these other questions. A. Where do you believe it's differentiable? So for example, is it differentiable right there? And right there? Over here? So are there a lot of places it's differentiable? But are there also some that it is not? Okay, there are some. So sometimes when you have these questions, isn't it easier just to find the places that it's not? Right? And so do you see any on here? You told me you saw some. Could you tell me some places that, or just give me the x value of where it would not be differentiable? Are those stretching or are those, oh, yes. -3 and? So I've been told -3. Do you agree with that? X value -3 is right here, right? Ooh, I agree. And I was told, what was the other one? I'd say 2. Now 2 is definitely a problem over here, right? That's just a huge old gap right there. I think there's one more. 0, right? Because the 0 x value right there, right? It's one of those rapid changes. Again, if you cast it out one way and cast it out the other, that's no good, right? Now what about the endpoints? If I'm right here, can I actually cast out here and reel it in? I can, so I'm good, right? It just has an answer. And if I'm out here, can I cast this way and reel it in? Yes, we're good. Don't worry about the endpoints. Unless there's a hole there, and then you might. Anyway, so here's how I would say it. And you can say it however you want. You could sit there and do a bunch of little intervals, right? You could do it that way. So if you do it that way, maybe write this down if you want. You would go like this, -7, because I told you you could reel into that one all the way to -3, right? But then you'd not include that, right? There'd be a lot of these, right? Do you agree that would take a while? So let's maybe write this different. And you can write it that way if you want, it doesn't bother me. But would you agree I would write it this way, all points from -7 to 6, and then put except. Because there's only a few of them, right? And then just list them. And what did you tell me? You said except x equals -3, 0, and 2, right? Have we kind of narrowed it down, right? So now you see why I went and got domain. You see how that was helpful there? Okay. Is there anything wrong with doing it the other way? Not a bit. I think these next two are pivotal. You can tell me these next two. I think you got this pretty well figured out. Has everybody had a chance to finish A there? Yeah, okay. So B, we have to find a place that it is continuous, but I can't take the derivative. So don't you agree I should be looking at, by the way I wrote it, I should be looking at those as possibilities, right? Now, is it necessarily going to be all of them? No. So we have to find a place of those possibilities. Is it continuous, but then I couldn't take the derivative? So let's take them one at a time. How about at -3? Well, way to use red. That's just a great plan. -3. Is it continuous? And you already told me I can't take the derivative there, so does that meet the requirements of B? Okay, so there we go. X equals -3. Okay, let's try the next point. 0. 0 points. Is it continuous?
Yes.
Okay. And you're telling me, oh, okay. And, well, there you go. 0. And the last one, 2. Oh, yeah, that's a problem, isn't it? Yeah, it's not continuous because basically that limit and the y value are not the same, right? Because it's a limits come into 2 different numbers, right? No good. Well, there you go. And C says neither continuous nor differentiable. So again, if I'm looking for places that it's not, I'm going to look at these 3 values again, right? But if I've already said -3 and 0 are continuous, I'm not going to also say that they are not continuous, right? So there are only options 2. So do you agree that at an x value of 2, it is neither continuous nor differentiable? All right, so x equals 2. And now you see why I probably wrote it this way, to try and lead you down that road. Yes? Hole in the middle. Oh, you mean like, say, right here or something? Okay. The question there was, what if there's a hole kind of right in the middle of things? Remember, when we do derivatives, we're saying I'm at this point. Here I am, and I'm casting out that way. I'm reeling it in. And then I turn around, I'm casting it out that way, reeling it in. But you have to be at that point. Can I be at that point? Yeah, you'd fall through. Yeah, that's a discontinuity. Yeah, you're in the lake, basically. You're in no boat. Okay, you fell through. Okay, and so is it continuous? No. Is it differentiable? That particular point? No, I can't cast. I'm in the lake. All right? Probably. Yes. The differentiable, the answer you're actually looking for is the slope. So you're saying basically, is there some slope that I can find there? Is the slope going to come to the same value both ways? That's what you're really looking for. And when we have a cusp like this, when you cast and reel in from the 2 different ways, it's going to 2 different values. They're not the same. Those slopes, not the same. Now, are they going to the same y value when you cast on this one? Yes, they are. Okay. So that tells you that the limit is, but not the limit of the slopes. That's the difference. Okay, good question. I don't think I made that distinction earlier, so good question. So first thing you've got to do is have some fun graphing that piecewise function. Or we're kind of running out of time, so we'll just put it in there. So that first one's right here. That's green. This is a line, so I'm hoping you're realizing it's that one. And what color do I need? Red? This last one isn't. Yeah, that's true. The graph is red. But there you go. Those are the pieces. Do you agree that this first one is an upside down parabola, though? Okay. This is the second one's a line, and then that one's right there. Right here, that is a hole right there at the end. So what is that? 5, -1. It looks because the equal to is not on the 5 here, and so I was not allowed to graph that point at 5, comma -1. And all I found that I just put 5 in to find out it was 5, -1. Okay. A lot of times, what you can do when you have these problems, if you know what they look like, just start putting in these end ones and find out where they go. And that's all I do. Especially if you know what it is, just put in the end points. And the reason I gave you the graph, because you're getting pretty good at them. You're not great yet, but you're getting pretty good at the piecewise. But in the next few minutes here, I want you to get the graph on there, and then do domain range, and then do parts A, B, and C from up above. Okay? And why don't you take some time to get that done? All right. Let's start with domain and range. Domain. Okay. Is that correct? We could have looked here. -4 including to 5 not. Well, if they put them in order. Yeah. All right. Range. -10 to 1, 2, 3, 4, 5. And including. Right? It's right there. Not X, at Y. 1, 2, 3, 4, 5. See? All right. So A, what was A again? Differentiable. Okay, so again, you could start with, oops. I would start with all points. -4, 5. Now, do I have to say except 5 then, if I write it this way? No, I already have, right? I've already said that 5 is not part of this deal. All right? We've already kind of stated that, okay? So, except, so now we got to look. X equals -1, right here. There is a definite change because the slopes are kind of working this way if you reel it in, and these slopes are working that way if you reel it in. That's not the same. That's like a turn here and a sharp, that's not good. And what else, where else did you say? 2, so down here you're saying? I agree. Once again, those slopes are going completely different. And you've already said 5. Is it okay if you say it again? Well, that's not the end of the world. You've already said 5's not part of it, but if you want to really emphasize it, well, then you can again. All right? All right, what's B then? Continuous, but not differentiable. So the only points we got to look at are the ones that we've kind of come up with, right? And so we got to look there. What do you think? Is that continuous? Yes. Yeah, but not differentiable. So what was that, -1? The slopes are going to different values, yes. And right there? Right. Again, do you have to worry about 5? No. But once again, can you really cast out this way and reel it in? No, not if you're not at that point. You can't. Okay? And you don't have to worry about it because it was on the end anyways. And how about C? Because what's the question? Neither continuous nor differentiable. It's not even in our domain. 5's not even in our domain, so how can it possibly be? Yeah, 5 parentheses, not including 5. So say that one more time. Yes. As far as this last one, yeah, it was actually in the domain, yes. Had it not been in the domain like one of these, we would have taken care of that way up here. And this would have been different. So yeah, because we would have taken care of that. As it even says here, determine which domain values, right here. So if it's not in the domain, you don't have to say it, because you've already gotten rid of it. Blank. All right.